on solving systems that have 3 variables, 3 equations. It's not going to be a situation where you have like z equals something specific. So, all right, so we have x plus y plus z equals 0 as equation 1. So if you added together the together the x plus the y plus the z, you would get 0. I'm sorry I'm writing so small. It's just that in order to see all of this at one time, I needed to shrink it a little bit. So you have x plus y plus z equals 0. Your second equation is 2x minus, that's a minus 2y, plus 3z is equal to 13. 2x minus 2y plus 3z equals 13. Yeah?
Will they ever be out of order, like x, y, z?
Well, if they are, then you got to put them in order.
Right.
Negative 5x minus y minus z is equal to negative 8. And by the way, these are your notes. You can use them as your notes. I think a couple years ago when I did this, I had them watch a YouTube video on it, so I'm trying it a little bit different this year. There is a YouTube link here. The link is a couple of years old at least, so maybe the video is not even there anymore. I'm not really sure. But if you do want to watch it, you can try and see if it will work for you. But step number 1 when you are solving a system like this is to either get rid of the x's, get rid of the y's, or get rid of the z's in 2 of the equations. So step 1 is to get rid of.
I like notes like this.
1 variable. In 2 of the equations. So you have to pick 2 of the equations, and you have to get rid of the variables. You have to eliminate a variable. Just like you did when you were using elimination earlier in the unit, earlier in the chapter. So let's look at our 3 possibilities. We have equation 1, equation 2, equation 3. By the way, it's really important in these things that you number the equations 1, 2, 3, and we're going to be creating, as you guys should probably notice here, we're going to be coming up with equations 4 and equations 5. So let's look at our 3 possibilities here. What variable do you think would be very, very easy to get rid of right now?
From 1 and 3.
We pick 1 variable. We got to get rid of 1 variable.
Why?
Get rid of y. Where can we get rid of y?
In the first and the third.
In the first equation and the third equation. All right, so let's do this. Write down the first equation. I'm going to number it equation 1. Equation 1, we have x plus y plus z is equal to 0. And then Marcus said the third equation. So I'm going to write down the third equation. The third equation is negative 5x minus y minus z is equal to negative 8. And if I added those together, those equations together, what would happen? The y's would go away. Would you agree?
Yes.
Okay, which is the whole goal of adding together equation 1 and equation 3. So we have x minus 5x is negative 4x. Oh man, we have z and a negative z. I didn't want that to happen. Z didn't even notice it.
Out, yeah.
Z and negative z are, that's okay though. Z and negative z are going to cancel out. Those are going to cancel out also, and that's going to leave us with 0 plus negative 8, which is negative 8.
I like that.
Okay? So we have a negative 4x is equal to negative 8. So what's x?
2.
X is equal to 2. So we already have one of our variables. Now what we need to do is figure out what another one of our variables is. And I was not expecting this to happen. So what I would like you guys to do, remember the goal of this, as Marcus said, was to get rid of our y's, right? So normally there would be z's left over, So what I would like you guys to do is write equation 4 like this instead. Negative 4x plus 0 z's is equal to a negative 8. And the reason I want is I want there to still be 2 variables left over so that we can use those 2 variables to come up with 1 variable. And you'll see where I'm going with this in just a second. Step 2. Step 2 is to do exactly what we just did, but this time what we need to do is eliminate the exact same variable, which means we need to eliminate what? We need to eliminate y again, but we have to eliminate y using different equations than we first did it with. So step 2 is to get rid of the same variable with 2 different equations. So pick 2 different equations up there. We are not going to use equation 1 to 3. We're going to use equations. We gotta get rid of the y's again, but we can't use 1 and 3. What else do you think we could use? Could we use 1 and 2?
Wait, I thought you said 2 different ones. Could we use the fourth equation?
No, when I say different ones, I mean you can't use 1 and 3 again. You can use 1 again, you can use 3 again, but you can't use 1 and 3
So
again
you need to
together.
replace one of them.
You're gonna have to reuse one of the equations. I mean
Okay.
a different combination of 2
All right.
equations. All right, so what do you think? Should we use 1 and 2?
1 and 2.
Could we use 2 and 3, you guys?
Could.
We could use 2 and 3, but we also could use 1 and 2. So let's do 1 and 2, and I'm going to rewrite them again. So we have equation 1 is x plus y plus z is equal to 0. And we're going to also use equation 2, which is 2x minus 2y plus 3z is equal to 13. And our job is, remember, to get rid of the exact same variables. So what are we going to do? What do we have to do to these equations so that we can get rid of the y's again?
Multiply the first equation.
We're going to have to multiply the first equation by 2. Do you see why I'm doing that?
Yeah.
If I multiply the first equation by 2, these y's are going to become
Opposites.
2y. So I'm going to multiply everything here by 2, and that's going to get me 2x plus a 2y plus 2z is equal to 0. Are you still with me?
Yeah.
You multiplied everything. Make sure you multiply every single term, even after the equal sign. In this case, when I
At
multiplied
this
by
time,
2,
all juniors, if you could please report to the auditorium. At this time, again, all juniors, please report to the auditorium.
Are you in rage?
I even raised because they said 50 and not say 44.
Let's go again. I
The y's cancel out.
see Friday.
2x and 2x is 4x. 3z and 2z give you 5z. And then, of course, if you add together 13 and 0, you get 13. This new equation that we came up with is now called equation
5.
5. So we have 4x plus 5z is equal to 13. That is my new equation 5. And the last step, step 3, is to now use elimination with your leftover, your new, not your leftover, your new equations 4 and 5. So step 3 is to use elimination with equations 4 and 5. So this whole process is not hard. It's just tons and tons of many, many places to make mistakes. Equation 4. Equation 4 is negative 4x plus 0z is equal to negative 8. This is equation 4, and I'm going to label it equation 4. Equation 5 is 4x plus 5z is equal to 13. Now use elimination. When you use elimination, that's when you have to sometimes multiply one of the equations by something so that one of the variables cancels out. Thank you for staying today. Do you kind of get where this is going now?
Idea.
So the x's are going to cancel out now. And okay. So when I add these two together, these x's cancel out. We have 0z and 5z, that is 5z is equal to negative 8 plus 13 is 5.
Divided by 5.
So what's z? Z is 1. So now we know one of the variables. By the way, we know another variable too. Do you remember the other variable that we figured out early on? We
X
figured out
equals
that
2.
x was equal to 2. But now what we can do is we can kind of do back substitution now. We know that z is equal to 1. So let's say we didn't know that x was equal to 2. We didn't have that situation up here at the beginning when we easily figured out what x was. We just knew what z was. You take this z and you plug it into either that equation or that equation, and you figure out what the x would be. And then now you have your x and your z. Your job then would be to figure out, of course, what your y is. How are you going to figure out what your y is? Yeah, you're going to take that x and that z, and you are going to plug it into any of the top 3 equations. So I'm going to go back up here to equation 1. Look how easy that is to use. X plus y plus z is 0. We know that x is 2. We do not know what y is. We know that z is 1 is equal to 0. So we have 2 and 1 that can be added together, which gives me 3 plus y is equal to 0. So y is equal to negative 3. So I believe at the bottom of your paper, which you can't see up here, you have a place to write your final solution, x, y, z. X is equal to 2, y is equal to negative 3, z is equal to 1. So you would write your solution as 2, comma, negative 3, comma, your z value, which is 1. What do you think? Easy?
A lot of stats, but it's easy.
Yes, exactly. That's exactly what you should think. Okay. All right. I do, of course, have some practice problems for you guys.